So what we have here is a question. IQ scores have a mean of 100 and a standard deviation of 15. By the way, I don't know this to be actually completely true, but it's probably ballpark. What percentage of people have an IQ lower than 85? So there's two parts to this. First, identify what you're given. You're told that it has a mean of 100 and a standard deviation of 15. You also were told, I didn't write it on the board, but you're told that it's normally distributed. Usually things that are a very large characteristic of a large group of people usually are normally distributed. So you go ahead and say that this is normally distributed. I'm giving you that fact. The mean is 100, the standard deviation is 15. Now that's the characteristic of the population of people. Now, what percentage of people have an IQ lower than 85? When you're given these kinds of problems, sometimes you're asked, what's the probability of choosing a person at random and they have an IQ less than 85? Sometimes you'll be asked, what's the percentage of people that have an IQ less than 85? It's really the same question. You attack it the same way. So the first thing we want to do is just say and write down what we know. The mean is 100 and the standard deviation is 15. And if we really wanted to draw this, then the way we would do that is draw our little axis here, and our normal distribution would be something like this, right? Now the mean we already know is 100. We could put the standard deviations in here, but ultimately all we want to know is what percentage of people have an IQ lower than 85. So let's say 85 is somewhere over here, and so usually we're trying to find, when we're trying to find something lower, we're trying to find the area all in this tail here. So ultimately we're going to read it right off of the chart, but we have to convert it to a z-score first. So ultimately what we want to find is the probability that a random variable x is less than 85. So I'll put that is equal to a question mark. That's what we're trying to do. Remember, random variable is just sort of the outcome of your experiment. You can think of it in terms of you're pulling something, what's the value you're going to get? You do that experiment again and again. It represents your unknown value. So what is the probability that if I pull somebody from the population that their score is going to be less than 85? Well, we can't do it as is. We have to convert these z-scores because we have to use the table. And so what we're going to do is convert 85. So it's the value minus the mean over the standard deviation. We have a value of 85 minus 100. The standard deviation is given as 15. So when you think about it, this is negative 15 divided by 15. You're going to get a z-score of negative 1. All right. So ultimately, we want to know the area to the left of the z-score, which is exactly what is given to us in the table. So the way you kind of write it all out, there's many ways you can do it. I'm just trying to get you familiar with things. The probability that when we draw somebody at random and their score is less than 85, our random variable is less than 85, is the same answer as the probability of getting a z-score less than negative 1. Less than negative 1 because we convert that and get negative 1. So we put negative 1 in the chart and we get an answer of 0.1587. This is a decimal, it's a probability. That's what we get out of the chart. So if the problem were phrased differently and it said, what is the probability that a randomly drawn person has an IQ less than 85? This would be the probability because that's what we did. We looked here, we're getting this area, we convert to a z-score, this is the probability. But that's not what the problem said. It said, what percentage of people have an IQ lower than 85? Think about weather forecasts. Weather forecasts are just percentages too. I mean, if it's 50% chance of rain, that's a 0.5 probability of happening, basically. So all you need to do when you want to go to a percentage is multiply by 100. So when you take this and multiply by 100, you can write the answer directly. 15.87% of people have IQ less than 85. And that's the answer. If we were asking for the probability of a person drawn, you would circle that. If we're asking for the percentage of people in our population, then you can easily find that as well. Because when you think about it, if this represents your entire population of everybody, if you add everybody up, then that's 100% of the people covered. So the area represents the probability of pulling a single person and getting a score in that range. It also can represent sort of like a percentage, like a weather forecast. So the second part here says, in a similar way, what is the what percentage of people have an IQ greater than 130? So if I wanted to draw that, I have a normal distribution here, right? And I have, what is the average score? It's 100. And so IQ greater than 130, this is 130. And so I'm trying to find essentially what is that surface area right there. What is that surface area? So let's convert to a z-score. Z is equal to x minus the mean over the standard deviation. 130 is the number I care about, minus 100 over a standard deviation of 15. So when I do this math, this becomes 30 on the top divided by 15. You get a z-score of 2. So we try to write our answer down, see where we get. So what we're trying to find out is the probability that our random variable x is going to be greater than 130. Let's find that probability. But we use the z-score idea to figure out that that's the same thing as the probability of having a z-score less than 2 or greater than 2, right? So we're basically converting this problem into a problem with z-scores, which is what we've been doing all along. But we cannot look this up in the chart. We can't, because the chart gives us shaded areas to the left. So because of that, we need to further change this and say z is less than negative 2. And we've discussed that many, many times. So whenever you do this, what you get, when you look negative 2 up in that table, and you look at the answer, you get 0.0228. So this is what we would circle if I asked you, pull a person at random, what is the probability that their IQ is greater than 130? This is a probability, but that's not what we're asked. We're asked for a percentage. So just multiply by 100, move the decimal spot 2 times. So we'll say 2.28% of people have IQ greater than 130. 2.28%. That's a fairly high IQ. Anything greater than that, you're starting to get into serious high IQs. Okay, so that's the basic idea. A lot of these problems are going to look similar after a while. That's exactly what I'm driving for. I want you to get comfortable with that so when you're on an exam or test, you're trying to calculate something, you're not worried about it. You need to be able to look at data, look at the mean, look at the standard deviation, know that it is normally distributed, and then draw a picture of that so that whenever you calculate the z-score, you know exactly what shaded area you're trying to get, and you use those charts, and it gets totally like the back of your hand. Because as we go on in statistics, we're going to be getting into other things that can trip a lot of students up. But if you have the foundational material rock solid, then that's going to build a huge skill set for you to achieve and do well in statistics. Learn anything at mathandscience.com.